If you can learn to recognize special cases, it can save you a lot of time in factoring. So what we're going to look at right now is factoring trinomial special cases, specifically perfect squares. Now these perfect squares come about by taking a binomial that is squared. So first plus last squared, or f plus L times f plus L. So let's look at what happens when we FOIL f plus L times f plus L. We would have first times first squared, outside times outside, plus FL, inside times inside, plus FL, and last times last, plus L squared. So what we get is f squared plus 2FL plus L squared. This is what's called a perfect square. There's a second perfect square that is made by taking f minus L squared, or f minus L times f minus L. We'll have first times first is f squared, outside times outside, minus FL. Inside times inside is also minus FL, and then last times last is plus L squared. So this is equal to f squared minus 2FL plus L squared. So there are some things in common between these perfect squares. First of all, the O term and the I term are the same if you were to FOIL them out. So you have those doubles. They both start with the f squared, they have the 2FL in the middle, and the end in the L squared. So there's actually formulas for these that don't use the letters F and L, and those are perfect squares formulas. They use A and B, so A plus B quantity squared is equal to A squared plus 2AB plus B squared, and then A minus B quantity squared is equal to A squared minus 2AB plus B squared. So this pattern can help us factor some trinomials, but they have to have very specific characteristics. So we can use this pattern to factor some trinomials. The trinomials that you can factor with this pattern have three important characteristics. The first characteristic is that the first term has to be a perfect square. So you have to start with a perfect square. So the first term must be a perfect square. Then you can use that term. That term would be something f squared. So we can figure out, by knowing what f squared is, what f equals. So f equals blank. Then the next thing we'll check is to see if the last term is a perfect square. And that's that b squared at the end, which we called L squared before. So knowing what L squared, if that's a perfect square, that can tell you what L is by looking at what times what gave you that. Then the third characteristic is that 2AB or 2FL in the middle. So the middle term is going to have to be 2 times F times L. And then the sign of the middle term will tell you if it's f plus L squared or f minus L squared. So if all three of these are true, then you can factor your trinomial into f plus or minus L squared, depending on the sign of the middle term. So when you see a problem that you think might be a perfect square, you're probably going to be suspicious because the first term and the last term will be perfect. So we'll check all three characteristics. First term has to be a perfect square. Second term has to be, last term has to be a perfect square. And the middle term has to be double the product of that f and L. If all three of those are true, then we'll just factor it quickly into either f plus L squared or f minus L squared, depending on the sign of the middle term. Let's look at some examples to practice recognizing this pattern. Four x squared plus 20xy plus 25y squared. We're still going to start these factoring problems the same way we were, which is checking to see, is there a greatest common factor? Sometimes what doesn't look like a perfect square ends up being a perfect square once you take out a GCF. So is there a common factor between 4, 20, and 25? No, there is not. Then we look to see, is that first term a perfect square? And if it is, then what times itself would give you 4x squared? Well, 2x times 2x gives me 4x squared, so that's going to tell me that f is equal to 2x. Then I move on to the last term. Is the last term a perfect square? So can I take something times itself to get 25y squared? Yes, I can. 5 times 5 is 25, and then y times y is y squared. So the L is 5y. Then the third thing I'm going to check is, does 2FL make my middle term? So 2 times 2x times 5y would be 2 times 2x is 4x times 5y is 20xy. And that does match. So I just double check that with that middle term, and yes, it is a match. So then that allows me to factor into f either plus or minus L quantity squared. So I'll go f, which was 2x, and then I check this sign right here to tell me if it's plus or minus. So this time it's going to be plus L, which was 5y, and then squared. Now you could still factor these perfect squares by guess and check, but if you get good at recognizing the pattern, it will save you a lot of time in the long run. So let's practice a little bit more. Okay, 50 minus 40v plus 8v squared. So if I'm factoring this, I'm going to start with a greatest common factor. Let's see, 50, 40, and 8 are all divisible by 2. So that will be 2 times 25 minus 20v plus 4v squared. And now I'm starting to get suspicious. Before, I didn't really think about perfect squares, but once I take out that 2, I can see a 25 and a 4v squared, which makes me think perfect squares. So I'll try the first term. 5 times 5 is 25, so f would be 5. And the last term, let's see, positive 4v squared, so 2 times 2 is 4, and then v times v is v squared, so 2v. And then the third thing I check is 2fl, so 2 times 5 times 2v. 2 times 5 is 10 times 2v is 20v. And I'm checking that against the one that I've already taken out the greatest common factor. So that 20v does match. So I can start factoring this. I'm going to remember to keep my 2 out in front, so 2, and then it will be f plus or minus l squared. And in this case, f is 5, so 5. And then to see if it's positive or negative, I check the sign of the middle term, so 5 minus l, which is 2v, and then quantity squared. A lot of times people then will ask, well, what happened to the middle term? Because now we only have 2 terms. But if you FOIL that out, you will find that that middle term is there when you FOIL the 2 binomials back out. Okay. How about 100x squared minus 60x minus 9? First of all, is there a greatest common factor? 100, 60, and 9. There's not. Then I go through my questions. First, is the first term a perfect square? Yeah, because 100 would be 10 times 10, and x squared would be x times x. Second question, is the last term a perfect square? What times itself would give me negative 9? And that is not going to work. Since 9 is negative, this is not going to be a perfect square. Because the perfect square pattern always has to end in plus L squared. Just because it's not a perfect square, though, doesn't mean that we give up. You would still be able to go back and check it and try and factor it by guess and check. So it's not a perfect square, but it might factor by guess and check, which is what we had used before today, where we look for first times first and then see if it's plus minus, minus plus, or plus plus or minus minus, and fill in the L term and then check with that O and I term. We're not going to do that now, but don't give up. If it's not a perfect square, try other methods. What about 20x to the fourth minus 20x squared plus 5? First thing to do is look for a greatest common factor. Looks to me like all of these terms are divisible by 5. So that would leave me 5, and then parenthesis 4x to the fourth minus 4x squared, and then plus 1. Don't forget that plus 1. When you divide 5 for that greatest common factor out of 5, you're left with a 1. Then we're looking, oh gosh, is 4x to the fourth a perfect square? Yes, because 2 times 2 is 4, and then to get x to the fourth, I would take x squared times x squared. Then the last term, what times what gives you 1? Well, that's a 1. And then we want to check 2FL. 2 times first, which is 2x squared. So 2 times 2x squared times last, which is 1, is 4x squared, which matches that middle term after I took out the greatest common factor. So I will factor it into 5 for my greatest common factor times f, which was 2x squared, and then it's going to be minus L, which is 1 quantity squared. The last problem we're going to do of this type is 9x squared minus 27x plus 81. First step, is there a greatest common factor? Yes, all of those terms are divisible by 9. So that'll be 9 times x squared minus 3x plus 9. In those three questions, is the first term a perfect square? What times what gives you x squared? That's just x. Then is the last term a perfect square? What times what gives you 9? That'll be 3. Then the third question is 2FL a match? So 2 times x times 3 would be 6x. And when you check it against this, that is a no. So again, that tells you it is not a perfect square. But we should not quit there. Just because it's not a perfect square, then we shouldn't quit. We should just try guessing and checking. So, not a perfect square, try, guess, and check.